This lesson is on the law of sines. And the nice thing about the law of sines is similar to the law of cosines. It works for acute, right, and obtuse triangles. So you're not stuck having to use it only on right triangles. This will work for different situations. And again, we start with a triangle, and we're going to label the vertices with capital A, B, and C, and the sides across from those with lowercase a, b, and c. This formula is the law of sines, but really you only use two of them at a time. So basically we're looking at this. A side over the sine of the angle across from it will equal another side over the sine of an angle across from it. And so again, like I said, you'll really only use two of these at a time, so you can just deal with a normal looking equation. Okay, when do we use it? There's two times. One of those is when we are given two angles and a side with the same letter as one of the angles. So two angles and a side that's going to match. So that's different than the law of cosines. And then the other time is when we are given two sides and an angle with the same letter as one of those sides. And I put side-side angle. This is the one that you can't say from geometry. This is where we need to use a flowchart that I have made, and I'll show you in just a minute. Because when you have this situation, you might have no solution. You might have one solution, or you might have two solutions. And so I've kind of condensed what can happen and put it into a flowchart that you can use to decide which kind of problem it's going to be. Before we get into that, though, I'm going to do an example of the first kind, the two angles and the side with the same letter as that angle. So here's example 1. Again, we're going to solve this triangle. We have two angles and a side that's letter is across from one of those angles. It matches that angle. You don't have to use a flowchart when you're in that situation. So the first thing that's we're doing is solving again. So you got to find all the missing parts, and the easiest thing to find is angle A, because I already have angle B and C, and all the angles of a triangle have to add up to 180. So angle A is going to be 180 minus 102 minus 29, and so angle A is going to be 49 degrees. There's one of my answers. I also need to find, if you look at the sides, I just have side B, so I need to find side C and side A. I'm going to start with side A, and since that's what I'm trying to find, I'm going to start with that one, and underneath that goes the sine of angle A, which we just found. So sine 49. And then for the other fraction, I have to use the one where I know both parts, and that would be B, because I know the angle and the side for B. Otherwise, I'll have too many variables and won't be able to get anywhere. So sine 29, so 27.4 over sine 29. Now, you just have an equation where you can cross multiply. So I'm going to do A times the sine of 29 equals 27.4 times the sine of 49. And it might help some of you to go ahead and type those in your calculator and think of them as numbers, decimals. So the sine of 29, if you type that in, you're going to get 0.484. And then this whole side, you can type in just the way you see it. You get 20.68. And then it's just a really simple one-step equation. Divide by the 0.484. So 20.68 divided by 0.484, and you get 42.7. So there's our side A. And then we're only missing one thing, and that's side C. So I'm going to do the law of sines really similar to what I just did with A. So I'm going to say side C over the sine of angle C. And again, I'm going to go back and use the B because I know both of those parts. And even though I know the A parts here, I've kind of rounded some, so I want to make sure I have the exact amounts if I can. So I'm going to use 27.4 over the sine of 29. And again, cross multiply, so C times the sine of 29 equals 27.4 times the sine of 102. And type that in, I get C times 0.484, and this side over here is 26.8, and then I just divide by that 0.484. And I get 55.4, and I have solved my triangle. I have all three pieces that were missing. Now once you get out your flowchart that looks like this, this is what I have created. You're not going to find it in your textbook. And I'm sorry that I can't get it to turn so that you can read it horizontally. But we're going to use this flowchart, and basically you start with the angle that you're given, and this is again the second situation for law of sines. You're going to start with the angle you're given. You're going to decide, is it greater than or equal to 90? If so, you're going to come up here. You're going to compare the A and the B. If the A is smaller, it's no solution. If the A is bigger, it's one solution. If you come back to the beginning and your angle is less than 90, you're going to come down here. You're going to compare A with whatever B sine A is, so you'll have to find that out. And if they're equal, it's one solution. If the A is smaller, it's no solution. And if the A is bigger, you have to come down and compare A and B. And in that situation, if A is bigger, there's one solution, and if A is smaller, there are two solutions. And so that's how you read this flowchart. So keep it handy, because we're going to use it in the next several problems, and I can't show you this screen and the other screen at the same time. Okay, so before we move to actually solving a triangle with the problem, let's practice using the flowchart. And so what I want you to do with this example 2, I have 3 different situations here that would be 3 problems that would be asking you to solve. And I want you to pause and see if you can come up with how many solutions that each is supposed to have using your flowchart. Okay, for the first one, again, when you're looking at the problem, the first thing you want to look at is angle A, and that in this case is 42, so that is less than 90, so you're following the bottom path. And then you want to compare A with B sine A. So I'm going to write down what we're actually doing here. So A, the 22, we're going to compare that with what 12 sine 42 is. And if you type that in your calculator, this is like 8.02, something around there. And so in this case, the A is bigger, and you follow the bottom path off of that block again. And it asks you to compare A and B. And obviously A is bigger than B, and so that follows the path that says one solution. Okay. Now, for B, I have X's and Y's. My flowchart has A's and B's. And so when you have a problem like that, you have to first look at the angle that they give you. And so that's X. That means your X's are going to be treated as your A's in the flowchart. So I'm going to think of this X as A and this X as a little a. And since our flowchart has the other letter be a B, I'm going to think of that Y as a B. So when I'm looking in the flowchart, that's how I have to look, because obviously I couldn't make the flowchart work with every single letter. You have to be able to understand what's going on. But again, start with the angle there. Alright, 85. Our angle is, again, less than 90, so we're following the bottom path. And the first thing we're going to do is compare A with B sine A. And so our A is 15, and B sine A would be 25 sine 85. And if I type that in my calculator, 25 sine 85, I get 24.9. So 24.9. In this case, the B sine A is bigger, the A is smaller, so we're following the middle path off of that block, and that leads us directly to no solution. Okay, our final example here, we have C's and B's. Our angle, 20.5, is a C, so in our flowchart, we're going to be looking at A for those C's. and then the B's B in the flowchart. So I'm going to start with the angle, 20.5. Again, that one's less than 90, so we're hitting that bottom path, and we're comparing A with B sine A. So I'm going to compare 12 with 31 sine 20.5. And when I type that in, 31 sine 20.5, I get 10.8. So 10.8. That means our A is bigger, and again I'm following the bottom path off of there, and I have to go to another block that compares my A and my B. The A is 12, the B is 31, so the A is smaller, and if you follow that line, it goes to 2 solutions. Now, if you had trouble with any of these or need help understanding that flow chart, then stop and raise your hand now so that I can explain it, because you really need to know how to use it before we move on. Okay, now we are to the next example, and this is one of those that you would need to use the flow chart on. So pause, use the flow chart, and decide where how many answers this has. And hopefully you realize that this is the same problem as we just did in 2C. So we know it has 2 solutions. So I'm going to show you how to do 2 solutions. And I like to just draw a line down the middle so I remember to do both solutions. And I call this side solution 1 and this side solution 2. Okay. Solution 1 is just working it out as if we had no problems, and just like we worked out example 1. So I have side C, side B, and angle C, so I need to first start by finding angle B, because that's the only thing that I have enough information to get, because I have both the side and angle of C, and I just have the side of B. I have none of the A information, and I can't get both of those A things without knowing something else first. So you're forced to find angle B first. So I'm going to start with that. The side B over the sine of angle B is going to equal side C over the sine of angle C. Cross multiply, so I get 12 sine B equals 31 sine 20.5, and then if I type in that 31 sine of 20.5, I get 10.85. I'm going to divide that by 12 so that this cancels, and the sine of B is 0.904. Now, this is one of those cases where you're missing the angle, so you have to do the inverse. So B is going to be sine inverse of 0.904, which should give you about 64.7 degrees. And so that is our angle B. Now, the next thing that I can find, because I have 2 angles now, is angle A, since my triangle has to add up to 180. So I'm going to do 180, and then minus the 20.5, which is angle C, and the 64.7, which was angle B. That gives me 94.8 as my angle A. So now I have all 3 angles and 2 of the sides. The only thing left to find is side A, and I need a little bit more room. And so I need side A. I have to put that over the sine of angle A. And again, I always like to go back to the stuff I know for sure. I know the C's. So side C and the sine of angle C. Cross multiply, I get A times the sine of 20.5 equals 12 times the sine of 94.8. And then the sine of 20.5 is about 0.35, and 12 sine 94.8 is about 11.96, and then I just have to divide and get A to be 34.17. So the first solution, again, it seems really normal, no weird steps taken. Okay, second solution is going to be supplementary. The angles B's are going to be supplementary. So what am I saying here? The first thing that we had to find, because we didn't have enough information otherwise, was this angle B. This angle B and the angle B that I'm going to put over here are supplementary, and that means that they add up to 180. So, just one moment, sorry. Angle B on this side has to add up to 180 with the angle B from this side. So 180 minus 64.7 will give me the angle B for this side. So we have an acute situation and an obtuse situation. Okay, after that connection, there's no other connections that we're going to work with. We're going to pretend like all of this given information and this angle B are their own problem. Okay, this is the only connection, is that these two angles are supplementary. And don't worry, you have to find angle B first, because you don't have enough information to get anything else. So that's always the one that you're going to be working with that's supplementary. It's not always going to be called B, but it's the first angle that you can find. Okay, now if I ignore solution 1 and just think about solution 2, I have side C, side B, angle C, and angle B. So I need to find something A, and I can find the angle because my angles of a triangle add up to 180. So 180 minus C and the angle B that we're using. And that gives us 44.2. So there is angle A. And then the last thing to do, I have everything but side A, so it's find side A. So A over sine of angle A equals, and again I'm going to go back to the C's, 12 over the sine of 20.5. Cross multiply A times the sine of 20.5. It's going to equal 12 times the sine of 44.2. And again, the sine of 20.5 is about 0.35. And this 12 sine 44.2 is about 8.37. And then I just have to divide, and A is 23.9. So that is how we get our second solution. Now, if you think you have it and you think you're good enough, you can stop the video now. If you want to see me do one more two-solution problem, I have another one after this. Okay, here's my fourth example for those of you who needed it. Again, I told you it's two solutions, but if you need practice with the flow chart, you may want to make sure you get that same thing off the flow chart. So I'm going to come over here. I'm going to go to my first solution, solution 1, solution 2. My first solution, I look at what I have and what I need to find. I have side A and angle A, and then side B. So the first thing that I have to find is angle B. And I can't find any of the C's because I don't have enough information to do a cross multiplying and just have one variable. So it has to be angle B, which means that's the first thing I'm going to find over here. But I have to find it over here using law of sines. So I'm going to do side B over the sine of angle B equals side A over the sine of angle A. And then I cross multiply, so I have 17 times the sine of B equals 18 times the sine of 63 degrees. So divide by 17. Sine of B is actually, let's do this. let's say 17 sine b, and let's type this 18 sine 63 in. If you type that in, you get 16.04. Now I can divide by 17, and it's a lot less to type in my calculator. And I get, okay, sorry. I am missing angle B, so I have to do B equals the sine inverse of 0.943, and that will give me an angle B that is about 70.65 degrees. And so there is my angle B for my solution 1. Let me roll down and do some more of solution 1. I still have not found angle C or side C. The first one I have to find is angle C, because when I know two of the angles, I can easily get the third one by subtracting from 180. So 180 minus the 63 and the 70.65 gives me 46.35, and that's my angle C. And then the last thing is to find side C. So side C over the sine of the angle C I just found equals, I'm going to do the 17 over sine of 63 and cross multiply. So C sine 63 equals 17 sine 46.35, and the sine of 63 is about 0.891, and the 17 times the sine of 46.35 is 12.3. And then I can just divide by the 0.891, get C by itself, and it's about 13.8. So that is solution 1. Now come back up to solution 2. And as we mentioned, this B and this B are supplementary, meaning they have to add up to 180. That's the only connection that we're going to make. So 180 minus the B from solution 1. It's going to give us 109.35. So this is the B for solution 2. Solution 2 now has angle A, angle B, side A, and side B. So I'm going to find angle C. All three angles of a triangle have to add up to 180. So 180 minus angle A and angle B will give us angle C to be very small, 7.65 degrees. And then I have everything but side C, so I'm going to do C over the sine of 7.65 equals the A over the sine of A. Cross multiply. And then if I type in, again, the sine of 63 degrees is 0.891. And then if I type this side in, I get 2.263. And I just have to divide by the 0.891 and get 2.54 as my side C. So I have two full solutions. Okay, that concludes this lesson.